Today, we're dealing with hand tool and power tool safety. So, certainly there's issues with various hand tools as far as safety goes, and then there's also even more complicated issues with power tools of various kinds. So, we will focus on, first of all, the construction standards that deal with hand and power tools. That's 1926 300 through .307. And then also got to keep in mind the general industry standards, which is 1910 241 through 244. With construction, we mostly focus with the construction standards. We're going to go through these things as we go. Tools become extensions of our bodies. We kind of can become complacent about how we use tools and about the safety of them. So you see this fella here, he's apparently doesn't have a sawhorse, so he's basically made one out of his legs. I've seen this many times before. Not ideal. The chances of cutting through your leg someday, if not today, is pretty darn good. So you need a good place to work when you're working with tools. Common hazard around tools is tripping. You can basically put a bunch of tools at your feet and you trip on them, or the debris that you're cutting off, like this guy is. He's got clippings that he's cut off, and those things you can trip on. There is electrical shock when you're dealing with electrically powered tools. There's other kinds of energy to worry about. There's cutting, and if you're dealing with a gasoline-powered tool, there's a good chance of fire. There's other reasons for fire to happen. There's sprains and cuts and eye injuries in particular, hearing loss, broken bones, plenty of things that can go wrong if you're not using the tool properly. So never use a tool that you do not have the training to operate. So get the training, get the experience, the skills. And one other thing I should point out is that you know that every tool comes with an instruction manual. It might be on a package with a screwdriver, and it might be just a few sentences of warning, but those are legal documents. The instructions that come with a tool are a legal document that OSHA can cite you for not following. They can just use the General Duty Clause, Section 5A1, to say that you are not using the tool in the way it was designed. Okay, so you maintain tools regularly, so plenty of tools need to be maintained. Okay, this guy in the bottom picture, he doesn't have a sawhorse either. Well, he does, right behind him. He has something he could have worked with better than making a new crack. Okay, so operating the tools according to the manufacturer's instructions, using the right personal protective equipment is important, and then many tools have guards that are part of them, whether they're a hand tool, like a cold chisel that has a big rubber guard around it. You should use that guard. Circular saw is what we've got in this picture down at the bottom, and up at the top, some kind of a miter saw, and they both have guards. Actually, that looks like that's a metal cutting blade, so it might be a chop saw up top. The thing is that they come with guards, and if you defeat them, or if the guards don't return properly like they're supposed to because they're clogged up with debris, they don't work properly. So you got to keep them in good working condition. So there's a number of tools that we'll be looking at here, including the powered or powered actuated tools. There are drills, circular saws like the skill saw you see up here. But we start with the hand tools. So there are hazards when you're working with any tools of dust flying around and vapors and fumes and mists, depending on what you're using. So this gets to something a little bit more generic. Well, first of all, the fire hazards. When you're dealing with flammable material for, let's say, a chainsaw, a lawnmower, a weed eater, any gasoline-powered tool or other fuels, there's the fire hazards. So we talk about fire hazards in particular with in the fire protection and prevention topic, but certainly it's an issue whenever you've got fuel-powered tools. So this picture is kind of a crazy picture. There's probably only one legitimate tool on this page, and that maybe that top hammer. Expensive. Yeah, right. Anyway, it's just sort of fun. But a hand tool is a non-powered tool. Well, it's going to be powered by you in the sense of using it. May include anything from axes to wrenches. Using the wrong tool for the job can be dangerous. If you start using a screwdriver as a wood chisel, you could drive it through your leg or somebody else's. So use the correct tool. Whenever you can use just exactly the right tool for the job, you look good because you're going to be much more efficient and you're going to be safer while you do the work. Repair, replace damaged or worn tools. Watch, for instance, for mushroomed heads on impact tools like cold chisels and wedges. When you build up a mushroomed head on these things, you can end up with some trouble. So, for instance, on this page down there at the bottom right corner, you see a mushroomed head, particularly on the most right-hand cold chisel. And those pieces that are mushrooming out there will snap off and launch like missiles at high speed while you're smacking on it with a hammer. And they can go anywhere, into your arm, go into your eyes if you don't have a proper eye protection, turn you into Scarface. And then above that, you see a hammer with a wooden handle, and the handle is damaged to the point where you cannot trust that handle to stay in place. Well, you may be hanging on the handle. You may not have the ball-peen hammer on the end of it. So again, you've got to examine your tools. And so the rule of thumb and what can be turned into a test question near you sometime soon is that when you're asked how often you should be inspecting your tools, the basic answer is daily. But every time they come out of your view, if you lend them to somebody and they come back, you need to check them out to make sure they're still in good condition. But daily, before you start using them. And of course, then you're monitoring the tools throughout the day, and so you know what the tools have been through. But you should be examining your tools with fresh eyes every day. Of course, using the right personal protective equipment, the hard hat, the safety glasses, safety goggles and gloves, work shoes, and many other things. Hearing protection. Keep the floor surface clean and clear that you're working on. Keep the tools sharp. If you use a chisel, a wood chisel that is dull, that can be dangerous. Using a utility knife where the blade is dull, that can be dangerous. So you can slip. You'll have far more control, far better control when you are using a tool that is sharp. Using a circular saw like a skill saw or even a sawzall or a jigsaw, scroll saw, any of these blades, if they're dull, you lose control. But it's particularly a problem when you're dealing with rotating blades, like on a table saw, radial arm saw, miter saw, circular saw. There's dust and suspended particles. I mentioned that, and that can be a problem. Just about any kind of dust you can breathe is harmful to your health in the long term, because some of the dust you may be able to cough up into phlegm and get rid of and spit out. Some of it you might ingest, and maybe that goes through as fiber. But the stuff that you breathe into your lungs, some of that will stay in your lungs. And it can be seen, a lot of it can be seen on x-rays. So silica and asbestos, but even sawdust, and being biological, it may not be quite as bad, but it still can be a problem. When you're dealing with fiberglass, for the fiberglass batting insulation, some of these particles will stay in your lungs. It's particularly true with asbestos and silica because the sharp dart-like fibers will, as you breathe them in, will stab the lung tissue and stay there. And then you grow growths around those things, those particles inside the lung tissue, and that part of your lung tissue can no longer absorb oxygen. So you actually reduce, over time, you keep reducing the amount of surface area of usable lung surface for absorbing oxygen just by breathing this dust. So do everything you can to reduce the amount of dust that you breathe in your lifetime. It'll help you as you get to be older when that really becomes an issue. It starts to culminate to a much deeper, more serious problem. Yeah, so short-term exposure can cause minor irritation to the eyes and nose and sinuses. Long-term exposure can impact your lungs, causing chronic bronchitis, pneumonia, and other disorders, including asthma, silicosis, asbestosis, mesothelioma, and on and on. Okay, so now we're looking at power tools. All tools can be dangerous, but when you add the power source to a tool, the risk factors increase. So here we are looking at the radial arm saw. It's a particularly dangerous tool in that it never had a very good guard system. But saws like this, the blade rotates as you're looking at it from this side clockwise, so it's spinning away from you. And that sounds like a good idea, but it means that if you were to pull this through the wood, if you take it, you got a storage area behind that fence where the saw can sit, and some people tend to pull it through backwards through the material. You're supposed to pull the saw out and then put the material in place and then push through. The blade should always be going forward through the material, not backwards. Table saw, the blade is spinning towards you. So as you're standing in the front of the table saw like this, it is spinning towards you, which means it can chuck the lumber your way towards you, or to anyone behind you. Again, you're supposed to be using the guard that came with the saw and use it as it's intended for. The guard has anti-kickback teeth. Even this saw here has some kickback teeth, but they don't work very well. Some of the better radial arm saws have better kickback teeth that can catch lumber that would normally be chucked. But the thing about a saw like this is at least the blade is spinning away from you, so the chucking happens away from you. Except that a radial arm saw, as I return back to this picture, you can bring it out and lock it at a particular position along this sliding arm and rotate it around so that you can rip lengthways 90 degrees from the way we're cutting right now here. That is this saw then becomes the most successful lumber chucker ever invented. I saw at a job site once where a 2x4 launched from one of these radial arm saws and went through the back windshield and the front windshield of a pickup truck. Kind of ruined somebody's day. But imagine if that had hit a person. Okay, so tools can be used for other purposes, hopefully not for dentistry. I just threw that in there for the fun of it. And marshmallow roasting, no, that's not normal. What this picture does, though, is it reminds me to point out that people often treat battery-operated tools as toys that you don't have to be so careful about how you use. So that when you're changing a bit or a blade in a battery-operated tool, many people do not take the battery loose when they should. So even a battery-operated tool needs to be treated seriously. But every tool, power tool, when you go to change the bit or the blade, you got to disconnect the power source, whether that's electricity from AC power, a battery on a battery-operated drill, or let's say a pneumatically powered tool, now a pneumatically powered drill, or other tools that are pneumatically powered. Remember, pneumatics, that's air pressure. That's an air compressor. Or if it's fluid pressure, hydraulics. There's other source, or gasoline power. You got to make sure there's no chance that tool can accidentally fire up while you're in the middle of trying to change the bit or the blade. And then when you've got tools with rotating shafts, looking down here at step 7, wear the appropriate clothing for the job being done. If you're wearing loose clothing, it can be tangled up in rotating shafts. So wear close-fitting clothing that cannot get caught in moving or rotating blades and rotating shafts of drill presses and saws of various kinds. If you've got loose sleeves, because maybe you've kind of unbuttoned them, you got to make sure you roll them up and get the shirt tails tucked in. Hair, long hair needs to be tied back. Oh my goodness, there's some of the most gruesome injuries from rotating shafts I've seen have been from hair getting caught in equipment. So, and jewelry, you shouldn't be wearing any jewelry on you when you work in construction or even around your house doing things that are construction related. Look at this picture here. This is a glove that got caught in a shaft here. There's some red in there signifying there's probably some blood involved here. And that's often what happens. Gloves, when they get torn off of you, by a rotating shaft, they sometimes take fingers with them, or at least the outer shell of the finger. It can be pretty gruesome. This next picture, well, the picture down at the bottom shows hair that got caught around that rotating shaft. Now, sometimes it doesn't just take the hair, doesn't just tear the hair off, it tears it out, including scalp. In fact, it can get worse than that. It can actually continue to go forward and tear off parts of your face. So it can be very, very gruesome. So rotating shafts, treat them seriously. Protect yourself. Do not let any loose clothing, gloves, hair get caught in them. So there are certain gloves that are better designed for rotating shafts, but there are some job sites that will not let you use any gloves around rotating shafts of any kind. Okay, anything here? I'm going to skip this page and kind of move on. In the interest of time, electrically powered tools. To prevent electrical shock, you should be using at least one of the following. Here you've got double insulated tools that are isolated, where the electricity is so isolated from you that you are protected by the very inherent design of the tool. Low voltage isolation transformer is a power source, so then you're dealing with lower sources of energy, lower voltage. Ground your tool with 3-wire cord. If you've got a 3-wire 3-prong plug on your tool, that's an important thing. So make sure that then you're plugged into a known ground. So normally with house wiring and building wiring, you've got that covered already in the original inspection. But when you're dealing with the generator, you got to make sure the generator is properly grounded. And then you should be using a ground fault circuit interrupter also that will check and sense ground faults and shut your tool down, trip the switch on the GFCI, the ground fault circuit interrupter, within a 40th of a second if it senses even 5 milliamps of energy leakage to ground. So these are things, that's something we talked about in the electrical topic. Extremely hazardous, of course, tools, they don't have the proper guards and safety switches. If you defeat any of these safety features, you make your tool a lot more dangerous. So there's different types of energy. I've mentioned some of them already, but here they are again. There's electrical energy, and it could be in a battery form or an AC power or low power transformer. Pneumatic energy, that's air pressure. There's liquid fuel, well, that's mostly gasoline powered tools like chainsaws and such. Hydraulic powered tools where you've got fluid pressure propelling everything. And then the last one is powder actuated, and sometimes we call it power actuated, but it's not baby powder, it's gunpowder. So we'll get to that. Okay, so let's see here. You shouldn't be abusing your tools like this guy by dangling it by the cord. The cords wear out prematurely when you're doing that. If you're yanking on them, you could be the cause of the reason. So you don't yank on the cords to disconnect them. You treat them like you're trying to preserve them forever and ever, like it's the last tool you'll ever have, and they'll treat you well. Double insulated tools will tell you, typically labeled somewhere and maybe more than one place on the tool. Generally, three-prong tools with a grounding pole, they're typically not going to be double insulated, whereas double insulated are two-prong tools with a polarity plug, typically, where one of the two blades is wider than the other of the two blades for the plug. Here's a worm gear saw. I had one just like this when I was 16 years old, my first real power tool that I bought. And I've got several of them now like this, where the motor is turned sideways and they have these worm gears, and it gives them tremendous torque. So much so that they are used sometimes as concrete saws, because you can just plow through concrete with the right concrete blade. Well, I remember being on a site where that tool was being used, but it had been used earlier for concrete, and it was caked up with dust, concrete dust. And so it turned out that when I went and used the saw, everyone else already had the saw set up, and I was joining them with my concrete crew to go in, and we were using the community saw in the plants. And I used the saw and then put the saw down, and then I felt some air, and I looked down, and I had a slice in my pants, on my thigh of my pants. Didn't draw blood, but my nice new work jeans were sliced through about 8 inches a slice, kind of thing. So what had happened is that the return guard that you see on the bottom of this thing right here is spring-loaded, and it's supposed to return back, and because it was all gummed up in silica and concrete dust, it didn't return. And so, I brought it down. Something has changed the way I use a saw ever since. But the point being that, first of all, make sure the tool, even when it's already being in use, look it over yourself. Don't trust anybody else. You check the tool out yourself. And so that was a huge lesson for me. Yeah. As everyone was kind of laughing around me about how close a call this was, kind of the dumb luck of the whole thing. And somebody else went and picked up the saw and used it, and then still, even though he knew about the problem, forgot and sat it down on the concrete, and it took off toward him like a go-kart where the teeth were digging into the concrete slab. So just because you know there's a problem with a tool doesn't mean you're going to remember at the precise right moment that the tool is in a critical place like that, So you can still end up forgetting. Pneumatic tools such as nail guns, chipping hammers, drills, jackhammers, sanders are powered by compressed air. So you've got basically an air motor, a motor that's powered by air that gets its supply from an air hose typically. And so they're great, they're wonderful. And in some places in the plants, when you've got special restrictions for what kind of sparks you can introduce to a job site, you might not be allowed to have a motor that has brushes where it produces sparks. You'll see them on the side of the motor through the cooling slots and stuff. So sometimes you'll switch to using pneumatically powered tools in order to get away from creating so much spark. But the reality is there's lots of other places that you can create spark with a impact hammer, a chipping hammer of chipping concrete. If you were to be able to do that in the dark where you could see it, not that I recommend doing it in the dark, you would see that there's spark happening right there where the chipper is hitting the concrete. And so there are plenty of other sources of spark to worry about when you're dealing with hot work. So the pneumatically powered tool here is kind of a cutaway, but it shows that you've got this diaphragm that loads up so that it can shoot a tool, something quickly in one fell swoop. Here we're looking at a fairly old-fashioned air connector, but when you get to a certain size of air hose, they are still often the connection of choice. Plenty of the quick connectors we have work fine up to about 1/2 inch on the inside diameter of an air hose. But by the time you get beyond 1/2 inch in size, you often end up with big connections like this. You quarter turn, you make a connection, and then you use some kind of a tie to hold it in place to keep it from slipping out by accident, because they don't typically have check valves built into this kind of a system. The old Chicago connection will blow around all over the place and pistol whip people. I mean, it can be a serious weapon. So we'll get to more details about that issue. But when you repair an air hose, you can't just do a homemade repair, because then you've got something that will hook on things and cause other issues. So yeah, you need a properly connected air hose. When you're dealing with a nail gun, you've got a muzzle that's part of the safety. That the muzzle has to be in contact with the work surface for you to be able to fire a nail. So you've got to be careful about not being lackadaisical about how you use these things. It can slip off and still launch a nail on you, a fastener, and let it go ricocheting around through the area. That's a problem. Blowguns, these little compressed air guns that you can buy for a couple bucks at Walmart and AutoZone and Home Depot and all kinds of other places, but they're everywhere. OSHA says that you cannot use these things above 30 pounds per square inch, no more than 30 psi. So I've tried them at 30 psi, and they don't really blow off the dust off your shirt or the table or anything. What they're worried about, anything over 30 psi, is you're launching particles at people's eyes and such. You're making airborne dust that people have to breathe and stuff like that. And so realize that they're really, you can't use them safely. That's what it really means. When OSHA says, instead of saying no, they've given you a restrictive number, 30 psi, you just try 30 psi and you'll see that it's not really a usable tool then. But that does make, when you're running a blowgun, it makes a lot of noise too, especially up at 100 psi where you're more likely to want it to be at. And hearing protection is an important issue on construction sites. Now, we've talked about them already in the personal protective equipment topic. Here it is again, and it's pretty much the same statement here. If you're exposed to sound levels that average at or above 85 decibels over an 8-hour time-rated average, you should be wearing hearing protection. And no more than 140 decibels of sound should you ever experience. That's when pain starts. So there's 115 decibels, you could experience that for maybe 15 minutes by OSHA's pathetic standards. But anyways, air hoses. So this is the thing I was talking about. When you get to a size of air hose where the inside diameter is more than ½ inch on the inside diameter, you need a safety excess flow valve installed at the source of the air supply. That's right at the compressor. So that if the air hose gets sliced, you don't have this angry snake blowing around of the air hose, getting a little poetic here, that's out of control, because it'll shut off at the source if there's way too much air blowing through, because it's a safety measure. So it's an important ingredient when you get a big compressor to have a safety excess flow valve in general set up on those things. Smaller compressors, when you're only dealing with smaller air hoses, not quite such the issue. Liquid fuel tools, of course, the most serious hazard with liquid fuel tools is you're dealing with fuel vapors that can burn or explode. But chainsaws are particularly dangerous in that, you've got this external blade on that bar, and it runs on the top, it's moving away from you, which means it's coming towards you on the bottom as you're cutting through. So it tends to want to pull away from you. Well, what happens is as you're cutting through a log, if the log binds in any way, if the chainsaw binds anywhere in that slot, it can do what we call kickback, and it can launch upward towards your forehead, basically. And so then you can end up with a chainsaw in your forehead, or worse. So we have basically an anti-kickback brake that is built into the larger chainsaws. You won't find them on the tiny chainsaws, but you'll find them on, any decent full-size chainsaw, where as it comes up towards your forehead, your hand will, there's kind of a red handle here, guard, and there's another one that's there's a handle and there's a brake. And so the idea is, the physics of the whole thing is, when the thing comes up towards your forehead, your wrist will have pushed that brake forward, and it locks to keep the chain from spinning, so at least when it hits you in the forehead, it's not spinning anymore. You might still have a scar, but you're not going to be sliced. That's the theory. However, when you cut from underhand, sometimes when this log is suspended after a storm and you're cutting from underneath, you can end up causing a kickback going the other way, when now it's coming towards your crotch, towards your legs. So there's a reason that they have these special chaff kind of protective gear that they wear on their legs for professional chainsaw folks, loggers and such. It's for some protection there. So the worst thing you can do is go up there and without proper protection when you use one of these chainsaws. The second thing is, of course, make sure you're using the reason they don't put them on the smaller chainsaws is they'll have a little surface there to kind of help you get control, but there's less force involved with a small chainsaw. When you get one of those little tiny chainsaws, even gasoline powered, they're lighter, And so there's a little bit less inertia, so a typical person can control that and keep it from hitting them in the forehead. But you get a 65cc engine on your chainsaw, there's enough horsepower there to overpower you. There's a lot that can go wrong when you're cutting trees with chainsaws, so I could go on and on about some of that, but usually gas-powered. Powder-actuated tools, sometimes called power-actuated tools. You see here, so powder or powder. They basically are 22 shell blanks or 25 shell blanks with no bullet in them, just the gunpowder. And they have different color coatings that they'll coat the tips or dip the tips of the shells in a paint of something. It's marked anyways with a color so that you have this standardized color chart that you see here, where the most powerful would be down at the bottom, the least powerful would be the number 1, gray, and as you go down to purple, you're looking at the most powerful, most gunpowder in there. And so one thing is that, first of all, you don't start off with the highest power. You don't want to start off with the highest shell. You want to work your way up as you try to figure out, well, first of all, what are they used for? They're used to shoot fasteners with great force, like a gun. It sounds like a gun, it acts like a gun, because it basically is. Where the fastener is shoved in the muzzle on the business end, on the end of the barrel, with a little bushing that keeps it from falling out. And then the shell gets installed in a chamber just like a normal gun. When you fire, it shoots that fastener into the 2x4 into the concrete, for instance, or into the sheet metal angle iron into the masonry wall or something like that. So it's used sometimes for fastening. It's used, maybe the most common place it's been used, I think, has been in when you've got partition walls, whether they're metal stud walls or wooden stud walls, to shoot the bottom plate to the concrete to make it hold from side to side so the wall doesn't slip out. Because, the interior walls that are not load-bearing are typically partition walls that are just there to divide up the rooms, and so they just need to be able to hold it secure so it can't move side to side. It'll stay put. So, yes, here's a kind of a cutout showing. In this case, you've got the little, I call them boosters here, but the shells. But I know the one that I have has individual shells, which also fit in 22s, by the way. And the fastener down at the other end, various kinds of fasteners to shoot into, whether you're different lengths, depending whether you're trying to shoot through a 2x4 and into the concrete, or through just some thin sheet metal into a masonry block or something. So they're a decent fastener. They're not good for something that's going to vibrate or anything. They're good for something that's pretty much staying put anyways as a fastener. But they sound like a loaded gun. It sounds like a gun going off because they are. So you have to be a little careful about where you use them too. The point here is where they're most dangerous is when you're shooting horizontally. So first of all, you're supposed to be trained and authorized, certified and authorized. So to be trained is to take some training from the actual company that makes or sells the tool. Typically, that's where you get it from. So there's different companies that make these tools. Ramset was one of the big ones, and Hilti, another big company that's made these things for many years. Remington makes them. So, and so that's where you get your training from, the manufacturer of the tool. So they'll have service reps that come out and do that training. And I say this, but plenty of construction jobs, that never happens. It's only going to happen probably in a very large construction company with a very mature safety program, or in the plants where they all have mature safety programs. So the trained part is you get in the training. The certification is the proof with the card like you see here. And then the authorization would be from your employer being authorized to use it. So make sure you've got all three. That's really true with many, many things, being trained, certified, and authorized. But you got to select the right power level that will do the work without excessive force. Here's what happens when you overdo it. Employee was killed, struck in the head by a nail fired by a powder-actuated tool. The tool operator was attempted to anchor a sheet of plywood form for preparing for pouring concrete, and it was enough load that it went right through the wall and kept going and struck somebody in the head. So you're really supposed to zone out the area completely so that it's not so that you don't have that hazard of people in the zone. You should never have anybody nearby who is on the business end of the direction. But the ricochet effect, you can still have trouble around you. So everybody should be wearing proper PPE that's anywhere in the zone. And so generally you have about a 50 to 100 foot zone around you when you're working with those tools. Okay, I moved on already here on the slides to hydraulic tools. So, and also just jacks in general. So hydraulic tools are powered by fluid pressure, hydraulic jack, backhoe controls, auto brakes, that sort of thing. Fluid pressure. So that's one issue. But jacks in general, you should never support a load with a jack. You can lift a load with a jack, that's what they're for, but you don't get up underneath your car after you jack it up. You put position stands. So I think most people know that. Well, the same thing is true when you're jacking up a big steel beam or a great big heavy concrete girder, or however you're lifting it. You don't let anybody get on anything when it's being supported by a crane or a jack, which you can't trust. You've got to support it with something that can't fail. The position stands for a car, some great big heavy timber maybe for the girder. So watch that language when they talk about, can you support a load with a jack? And you think, well, sure. No. Supporting a load means that you trust it enough you can climb up underneath it. This is part of the definition of that term in safety. So just be careful about that language. So here I've got it in item number 6. The jack should never be used to support a load. Once the load is where you want it, you block it up. You put cribbing or something like that up underneath it. You have to be careful when you're using hydraulics. In cold temperatures, you may need a different kind of fluid or some kind of antifreeze, and that stuff can freeze. So to set a jack up, the base has to be on a firm level surface. It's got to be centered properly. The jack head is placed against the level surface. You apply the lift force evenly, and then you've got to, of course, keep the thing maintained well. Every jack has a rated capacity. This one says 12 tons right there on the ink stamped on there. But a lot of times that's academic. Plenty of times you'll find that a jack, the most important thing isn't its lifting capacity. Long before you get to that lifting capacity, you could end up having to use a bigger or a different jack because of the stability issue. That's the most important thing. And it's hard for me to give you instruction on that, except to say that the biggest jack that'll do the job is the safest jack to use. That's probably the safest thing to say on that. But just understand the stability. If that jack flips out, and you have to think the whole time you're using a jack to lift up something very heavy, what happens if this jack flips out? Does everything come crashing down on me, on somebody else? So you've got to put yourselves in positions of safety. The manufacturer's rated capacity must be marked on it, and you cannot exceed that. That's certainly true. And then you're not supposed to exceed the extent of the length of the jack. So be careful on that. So here's an example where they use some cribbing to support what they're lifting here. Maybe not exactly perfect, but it's a good example of showing it. But it's better if the heavier timbers are better than what they've done here, but ultimately they don't have cribbing where the jack is at yet. They're only at the other end, so you can't go by that directly. So here's another crazy thing. I got position stands for the bug here on the back end. That's the heavy end. But look at the front end. All they've got is a big plastic mayonnaise jug here, so that's not good. And then here's somebody on the side of the road changing his U-joint. And he just had to use, for his stand, he was grabbing whatever he could. Well, it's less of an infraction than it seems like it's working. But here's the thing. Okay, a rock, maybe. You're not going to find any rocks that we can do that to around here in Louisiana. But in people use masonry blocks to lift up and support, particularly to support the load of anything from your scaffolding to your vehicle. A masonry block, you cannot trust that it'll stay put. You cannot trust that it won't shatter. It's like a piece of glass. So the rock, well, that's a big question mark. How strong is the rock? Many rocks are much stronger than that, but are you going to trust your life to it? Here's someone who got desperate. He's apparently needed to get up higher than what his position stand would help with, and as he was jacking it up, he ended up with all this creative mess. Not something very trustworthy. It looks like he needs new tires too. And then this guy, he's even worse. He's welding on his gas tank. That's not good. So when the tank explodes, he might bump that timber behind him, and it'll all go bad here. Okay, so now let's look at abrasive wheeled tools. So when you've got a bench grinder like this disc, this grinding wheel, is basically a bunch of sand glued together. So it's very possible for it just to shatter and to throw shrapnel all over the place. So you see the tool rest that you can actually grind on, kind of a little resting surface to grind on there. Well, this has to be within 1/8 of an inch of the wheel. And then up at the top here, there is a metal plate, this upper guard, and that guard has to be adjusted so that it's always within 1/8 of an inch of the wheel. 1/8 of an inch clearance. So here's the thing, as you use this over time, well, you can bump it and stuff where it can come unadjusted. But also the wheel's getting smaller. As you grind, it gets smaller, so it's going to naturally, even without any bumps or knocks, you got to keep adjusting it closer and closer over time. There's nothing really holding that sand together except a bunch of glue. Some of them have bamboo reeds inside them, and that's not asking for much. I mean, that's not that helpful. There's a test that you can do. If you've got that grinding wheel from here loose in your hand, kind of hold it loosely, and you can tap it with the handle of a screwdriver. It's what we call the ring test. If you don't hear a nice little ringing ping, maybe you hear a thud instead, and you're not muffling by how you're holding it, then you need to take that out of service and get a new wheel. So it's not the definitive thing, but it's certainly, if you hear a thud, you know that there's a crack in that thing. You better not dare try to use it, because looking back at this thing, if this thing comes apart, it can throw shrapnel right at your chest. That's what that upper guard is for, so that as it shatters, it's going to capture debris as it's flying around, whipping around and coming back at you. In general, with abrasive wheel tools like that one that we were talking about, or just angle grinders like what this blade is for, they have a maximum rotational speed, maximum RPM, rotations per minute, for the blade. And your tool has a maximum RPM rating. You got to make sure that the blade meets or exceeds the rotational speed of your angle grinder, or else it can just naturally, has no reason why it shouldn't fly apart and throw shrapnel at you. I've seen pictures of a couple times of people with chunks of this blade in their cheeks. Not a pretty sight. So there's a guard on the angle grinders, and you need to have that guard installed, and installed correctly for the person. And what I mean by that is, if you're right-handed, you're going to hold that tool a little differently than you will left-handed. You got to make sure oftentimes you have to take the blade off in order to change the orientation of that guard. But you need to do it. If somebody's going to use the tool one way or the other, you got to make sure you rotate that thing around. Some of the better tools have a simpler way for you to rotate that around, so that people are more likely to do it. But you need that guard to be protecting you from the shrapnel. Expect the tool to fly apart. Expect the blade to fall apart, I mean. So there's showing the 1/8 inch gap that you got to make sure you have no more than 1/8 of an inch gap. And you don't, of course, adjust it while it's rotating. It seems like an obvious thing to say, but you'd be surprised how many people don't want to shut the tool off and they're just going and bump it with a hammer or something. You're supposed to be guards on all sorts of tools, including the concrete saw. And as you cut deeper and deeper, and you typically don't cut all the way through with that blade in one pass. You usually make multiple passes. So you need to keep adjusting the guard to the right angle to protect you, depending what depth you're cutting to at the time. Guards for radial arm saws. There's guards on the front and back of a belt sander. But there's a certain little point where the blade is kind of going around clockwise as we look at it here. So that nip point is where that belt is returning back underneath to come around the other side. And if it catches clothing or skin, that can do some serious damage. So you got to make sure you keep your clothing and your body away from the belt at all times. And more guards to show you. The guard here. Make sure that it freely moves back and forth. So when you should pull it before you fire it up. You pull that guard back and then let it return to make sure it returns properly. So make sure that these hood guards work. And of course, the most important thing of these guards on table saws is the anti-kickback teeth that keep the wood from chucking at you. It's really important that is functioning properly. I don't see them so much anymore, but we used to see these little constant lock switches for drills so you can keep the drill locked on. There was something back in the 60s and the 70s where they were, maybe even the 80s, but not beyond, where the tools would have this button so that you could mount it in a jig as a drill press. And so Sears would sell these kits, and you mount them, and then you could say, I have a drill press. And then you could push that little button. You pull the trigger and turn it on, and you push the little lock button so it stays on. Well, I'm telling you, you can accidentally turn that thing on and lose control of your tool. And so it was less of a problem for a right-handed person than it was for me. I'm a lefty, so to me, I found those to be the curse. I hated them. I had to get very skilled to keep my hands away from those things. And a few of them I've been known to bite off with a pair of pliers just to get rid of the button. Okay, I digress. I'm grumbling here. But here we are kind of finally at the end of this section here. Again, at the end, I tend to have a summary. So first of all, hazards are used, just kind of a little bit of review since it's gone pretty well. Hazards are usually a result of improper tool use or not following one of them or more of these protection techniques. So you should inspect the tool before each use. Use the proper personal protective equipment. Make sure you're using the guards that come with the tool. If the guards are removable, like they are on a table saw, you got to make sure that if you needed to take them off for some reason, maybe to change a blade, or sometimes for some special jig you're going to put on the top of that table saw, you got to make sure afterwards you get that guard back on in place. It's important. Properly store the tools. Use the safe handling techniques. Use the tools the way they are intended for the job they are intended. Okay, so that was my initial summary, and then I put in some things that are generally inside the study guide for this topic you'll find. So yeah, the things that I have in red, particularly important. The common hand tools would include chisels, screwdrivers, and axes, but not jackhammers. The jackhammers are always going to be powered by either air or electricity. So pneumatics and stuff. So common pneumatic tools with nail guns, sanders, and drills, but not chainsaws. Although there's no reason why they couldn't make one, but you still could find a test question that trips you up on that a little bit. So just be careful. Common hazards using tools include tripping, electrical shock, cutting, and fire. Potential injuries include burns, cuts, sprains, electric shock, eye injury, hearing loss, broken bones. Number 2, I'm going to go down to the red only here for interest of time, but all these things can be important. But when using power tools, you should not wear loose-fitting clothing, and you should not wear long hair. Well, that means if you have long hair, you need to get it tied up. And you better make sure that you're not wearing rings on your fingers, no earrings in your ears or other piercings. You got to take them off, or they'll be ripped off, and then that damage will be miserable. We're talking about the powered tools, grounding your tool with 3-wire cord using double insulated tools or a low voltage isolated transformer, and then generally using, whenever possible, a ground fault circuit interrupter. It's one of the most important devices you can use for electrical safety around tools. Use a GFCI everywhere you work, and consider installing them in your house. And then, okay, summary 4, we might be at the end here. Let's see. Air hoses, I think maybe last page. If an air hose is more than ½ inch on the inside diameter, a safety excess flow valve must be installed at the source. These are things that can be turned into testable points, so that's why I'm emphasizing them a second time here. Long-term exposure to dust and suspended particles may cause pneumonia, and that's certainly true. And other things, including asthma, they can aggravate those things when you've already got them too. According to OSHA, you should wear hearing protection when the average noise level is at or above 85 decibels. So remember that 85 decibel level. It's an action level. We've got more of an absolute number of 90 decibels, but the action level is 85 decibels. And this is definitely the last one. I know that for sure. Let's see. The most serious hazard with liquid fuel power tools comes from what? From fuel vapors. They can explode or catch fire. The next one here on this page, only those with current training should use a powder actuated tool on a job site. And finally, it is not safe to use a jack alone to support a load while working underneath it. So yes, you can lift the load with a jack. You don't get underneath there till you've been able to support it with some dunnage, cribbing, position stands, some kind of structure that is engineered or foolproof. And so big heavy timbers are foolproof, even without. It's amazing how much load you can put on wood when you stack it properly. And then here for the fun of it here, that's a 10-inch table saw blade in that tool. May not be approved, but it didn't work. It worked very well at the beginning, and then it was fine. It's not particularly dangerous, but it's just kind of fun. Okay, so with that, let's call that an end to hand tools and power tools.